Welcome to mechanical tutorial. I am going to teach you different techniques in SolidWorks for mechanical engineers. I am going to train you different modules like surface modeling, sheet metal and enclosure design, product design, plastic components design, reverse engineering and many more tips and tricks in SolidWorks. Hi, today I am going to show you how to create the sheet metal component, and I am going to show you how to create the symmetric flanges with simple method, and as well as I am going to show you how to create the drawing in folded state as well as in flat pattern. So this is the model, and I am going to show you this drawing. So let's start now. So I've taken a simple SolidWorks part file. So I'm going to create base flange. So select the front plane, go to sketch, select a rectangle, (65). This is 40. So select the sheet metal module, select the base flange, and it's 2 mm. So K factor I am taking as 45. See. Now I am going to create edge flange. So you can create both edge flanges at a time. So select the two edges, top and bottom, and select the material inside and say OK. So now select this sketch and select this edge from outside. We have to select from always from outside to this edge. This is around 50. Now make these three edges construction. Now take a line and just move down, so you will get an arc. So it is not creating, so simply escape. So make the line other side and move it down, you get an arc. So it is not taking, so you can simply select the 3-point arc and select these two edges. Simply place it somewhere, select this point, make it tangent, make this tangent, select this line and this arc, make it tangent, and select these two lines, make it equal. This point and origin, make it vertical and say OK. Now this dimension is around 12.5 and say OK. See, so we have to make symmetric flange. So before that we have to go to view option and we have to make sure that this is not highlighted, hide all types, and we have to select this sketch. So this is highlighting. Now once it is done, may show this
sketch. See, the sketch is visible now. Now go to the sketch. So we can select this sketch and this sketch with control button, make it collinear. So it is constrained now. So these two are equal. Now select these three lines, make it construction. Say OK. Now select this line and this line, convert entity, and say OK. See here. Now right click and hide. See here. This is how we make symmetric flanges. This is the easy method, and whenever we modify one sketch, automatically it reflects on the other flange. Next I am going to create this cutout. So select this face, go to sketch. Here make it in wireframe and select this edge, make offset entity. So this is around 13. Say OK. Similarly select this edge, select offset and select reverse direction. This is 8 mm, and this edge also reverse direction, so you will get automatically 8 mm. Now select this outer edge and select convert entity. See, this is converted. Simply select this point, just rotate it and make it coincide. So it is a circle. See here, exact circle. Keep it normal. Now select trim entities, select power trim, just simply remove these outer lines and this one. We can use corner trims here, or we can use power trim. Now go to sheet metal, select extruded cut. So usually we select link to thickness, since we need both the directions. So I'll keep it in by shaded form. So uncheck this and make it blind. So select this arrow and move it down simply to other side, so it reflects on the other side also. So this is how we make the cutout. Next we have to select, I am going to create this hole. So select this face, go to simple hole feature. So here this is 10 mm, simply say OK. Now go to sketch, edit this sketch and select this point, move near to this edge. You can highlight as a point here, the center point, just make it coincide. Now this is defined sketch, it is fully defined sketch. So say OK. So once again we have to go to, if it is not created, we have to go to edit feature and we have to make it blind and make through all and say OK. So this is done now. Now I am going to create these holes. So select this base, go to sketch, sorry, we have to go to hole feature, select this hole and simply say OK. Now go to sketch. So hole feature, this is the best method. So this is 10 mm and move little bit left side. So we have to dimension. So edge to the center of the hole is 16 and this outer edge, if it is not selecting, keep it in wireframe, select this edge and this center point, so it is around 20. If you want to make it at center, we can select these 2 points and make it, so select these 2 points and we can make it horizontal, or we can give the distance if it is not at the center. Now make one center line from the origin, select mirror entities, so we have to select this circle, mirror about this center line, say OK. So now it is symmetric, so fully defined, we can move to this edge. Now say OK. See here, so this component has been created now. So next I am going to create this drawing. So first I am going to create a folder state, later I am going to create the flat pattern drawing. So I have taken a A3 sheet. So now I am going to insert component, so we have to select model view and select this component. See, initially I am going to keep it in front view, say OK, and I am going to place top view and side view and one isometric view. So we can drag it to required position, select this and keep it in shaded form. So if you want to show the dimensions, so go to annotation, smart dimensions, select this edge, and these 2 center points. So we can flip this, select this and simply select on this point, so we can flip the arrow. Now I am going to show you these whole dimensions. See here, simply select this dimension text and say 2 into x, because we have 2 holes. So next I am going to show you right side view. So I am going to show also the overall length of this component, and from right side view see here, so this is 50 and this height is 40. So in the top view, so this diameter is 10 mm, so we have 2 holes, so 2 into x. Next this is radius, here also we can mention as 2 into x. Select this edge and this edge. So we don't have to mention any overall lengths, because the volume of the component is mentioned 65, 50 and 40. So this is the simple drawing of this component. Now after placing drawing, we have to show the center marks, not before the dimensioning. Sometimes it may go to dangling if you give center marks before the dimensions. This is the thumb rule. Next I am going to show you how to create this flat pattern. So you go to model view and select this component, See, simply we can select the flat pattern. So it is not showing here. Even if I select flat pattern, so right click, go to properties. So we have selected the flat pattern configuration, but it's not showing. So we have to go to the component, right click and select this component. So now we can hide these sketches, hide all types. Now see, we have to unsuppress. See here. So this is the flat pattern configuration and folded state. We have to make sure that this component is in both the configurations. See here, this is in folded state and this is in flat. Now I want to rotate this component, so select this view and select this rotate view. Simply type 90 and apply. See here, close it. See, when we place any dimension at the arcs or any circular component, we have to place this point at this corner and this corner. So these are the start points and end points of the component. Simply escape. So I am going to delete additional point. Sorry. So now go to smart dimension, select horizontal ordinate dimension. So we have to place, this is the 0. Simply we have to click this circle, this edge, this circle, this edge, this circle. So further dimensioning, we can select these points also based on the requirement. Now go to vertical ordinate and select this and this circle, this circle. So here we can select 2 into x. Here also we have 2 holes, 2 into x. Now we can dimension these holes. There are 4 holes, so we can simply say 4 into x, or we can say 4 places. Sometimes we can place this isometric view. Simply say keep isometric, and better to keep shaded form for better understand. See, this usually this drawing goes for stamping or laser cutting based on the size of the component and thickness. So this is a folded state drawing and this is a flat pattern. So here I have shown you how to create drawing as well as a 3D model in sheet metal module. Thanks for watching.